So the next point of precipitation gravimetry is what are the factors affecting solubility of precipitation. So what factors affect the solubility of precipitation? So there are different uh, factors which are responsible or which affect the solubility of a precipitate. So the first is common ion effect. See here, the solubility of a salt is less in a solution containing ions in common with that of the salt than in water, provided the equilibrium is not disturbed by the formation of complex ions, is known as a common ion effect. So what it mean? Now see here, in another word, the solubility of the precipitate is decreased by the presence of other ions in the solution common with the precipitate. Means during the formation of precipitation, for example, if silver chloride is going to be precipitate, then if in a solution, if chloride ion ions are more, then precipitation of Ag plus is get increased, because in a AgCl, Cl minus are common with the ion which is present in the solution. So they have given the example here. During the precipitation of Ag plus ions from an aqueous solution containing excess of Cl minus ions, even small quantity of Ag plus ions in the solution can get readily precipitated, as Cl ions are present in excess. Because of presence of Cl minus ions in excess, the small amount of Ag plus ions are get precipitated quickly. Therefore, silver chloride is less soluble in presence of chloride ions than in water. This is what the common ion effect means. The solubility of the precipitate is that is, the compound is not going to be soluble because of the presence of excess of common ion in that solution. Therefore, this is the common ion effect on the solubility of precipitation. So the second effect is diverse ion effect or salt effect. The solubility of sparingly soluble salt increases, so it is reverse of this common ion effect. Here the solubility of salt is going to be increased, means compound is going to soluble when in presence of a foreign ion, that is ions which are not common to those of the salt. This effect is called as diverse ion effect or activity effect. For example, the solubility of barium sulfate BaSO4 is increased by 70% in 0.01 molar solution of potassium nitrate than in water. So here the barium sulfate is going to be dissolved more and more. It is increased by 70% in a solution of potassium nitrate. Means BaSO4 is more dissolved in potassium nitrate than water. Therefore, this effect is known as a diverse ion effect or salt effect. The third effect on the solubility is effect of pH. The solubility of substance depends on the pH of solution from which the salt is going to be precipitated. Means in which solution the compound is going to be precipitated or the salt is going to be precipitated, that the pH of that solution is more important here. The solubility of precipitate of salts of strong acids such as BaSO4, silver chloride is unaffected. Means these compounds are not going to be affected by change in the pH of that solution, but that of salt of weak acids is affected considerably. For example, precipitate of oxalates, carbonates, phosphates dissolve in presence of excess of acid. If you increase the pH, we decrease the pH or increase the amount of acid, then such compounds, that is oxalate, carbonates and phosphates, are going to be dissolved. So this is the effect of pH on the solubility of precipitate. So the fourth effect is effect of temperature. Generally, the dissolution of solute in a solvent is an endothermic process. So dissolution of solute in a solvent is an endothermic, that during the dissolution of solute, the solute takes energy from that solvent. Therefore, it is known as an endothermic process. Therefore, the solubility and solubility product increases with increase in temperature. Means if you increase the temperature, the solubility goes on increases and also the solubility product increases. For example, the solubility of silver chloride in water increased by about 20 times when there is rise in temperature from 298 Kelvin to 373 Kelvin. So only change in 75 degree, there is an 20 times increase in the solubility. However, during precipitation, the presence of excess of precipitant, that is common ion, decreases the solubility to such an extent that the effect of temperature becomes negligible. That we have seen in the common ion effect, if there is an excess of precipitant is there, that is common ions are there in the solvent, then there is no effect of temperature on the solubility. Therefore, the process of precipitation is carried out in a hot solution. So that hot solution helps to give a precipitate larger, uniform size and facilitate filtration, which becomes very fast. So this is the effect of temperature, that is increase in temperature increases the solubility. However, if there is a common ion present in the solvent, then there is negligible effect on the increase in temperature. Okay. So the last effect is effect of nature of the solvent. So solvent play an important role during this solubility of the precipitate. In general, like dissolves, like for example ionic salts dissolve more readily in polar solvents like water than in non-polar solvents like alcohol, benzene and carbon tetrachloride. So inorganic solids are less soluble in non-polar solvents like organic solvents. So if you change the solvent, the compound is not going to be soluble, or it may soluble. Okay, so there is a line that is like dissolves like. Therefore, ionic salts dissolve in water, but they not dissolve in the organic solvents. So the last is the controlling particle size. The purity and ease of filterability depends upon the particle size of the precipitate. That is, the purity and ease of filtration depends upon the particle size. In gravimetric analysis, when the ionic product exceeds the solubility product, precipitation takes place and the particle size formed by precipitation varies enormously. So these are the 6 different factors which affect the solubility of the precipitation, that is common ion effect, diverse ion effect, effect of pH, effect of temperature, effect of nature of the solvent, and the last one is the controlling particle size. So these are the different factors which are affecting the solubility of the precipitation.